Hi, what I'd like to talk to you about today is finding maximum values of functions on closed intervals. In some of your reading, you may have read about something called the extreme value theorem, which promises us that if a function is continuous and on a closed interval, that it will have a maximum minimum y value on that interval. While you're in a pre-calculus course and we haven't officially defined what continuity means yet, I can just say this, for the time being. A continuous function has the property that you can trace over with your pen without having to lift it at all. So if we look at this graph here, a function like this picture is continuous between its two endpoints because we can trace over it, and at no point while tracing do we need to lift our pen. That would be an example of a continuous function. Consider this next graph. Here's a graph that I'll show you a picture of it. If you were to attempt to do the same thing on this graph and you started tracing over it, you'd eventually reach this point, which corresponds to some x value down here on the x-axis. And at this value of x, we have to jump from these y values up here, up there at the top, to a lower set of y values over here. And because we have to lift our pen to continue to trace this graph, we're going to say that it's not continuous. Again, that's not a super rigorous definition of what it means for a function to be continuous. You are interested in a more formal definition, you certainly can ask your teacher. That said, what I'd like to do is get on to an example of finding our maximum minimum value of a function. So here's the example I'd like to consider today. Find the maximum and minimum values of f of x equals x cubed minus 4x on the interval -3 to 2. So to do this, the first thing you want to do is graph a function on the interval. I'll be using a T84 today. You can do the same thing on a T89. Subtle differences. Ask your teacher to help you out with that. So here we go. First thing we do is we go to y equals, and we're going to type our function in. So x cubed minus 4x. Oops. Be careful. I'm glad I made this mistake. Be careful with the TI-84. If you have a newer operating system, you have to hit the right arrow to get out of an exponent. So I hit the 3, and then I hit the right arrow, and that gets me out of the exponent. Minus 4x. So here we go. I hit enter. I take a look at it. It looks the way I want it to look. The next thing I need to do is take care of that interval. So let me just remind you, the interval I wanted to use was -3 to 2. You should recall this number on the left is usually denoted A. That's denoted B. So we're looking for our left endpoint of our interval to be -3 for x, and our right point of our interval to be 2 for x. So to handle that, what I'll do is I'll press the window key, and I'll go to x min, and I'll make that -3. And I'll go to x max, and I'll make that 2. And for the time being, I'm not sure what y min and y max should be, so I'm going to leave them -10 to 10 and hope that that gives me a good picture of my function. Next, we press graph. And we can see this picture forming, and this is good. We've got a good chance of seeing the whole function. What are we looking for? We're looking for high points and low points on the function. So if we hit the trace button, you can start to move around left and right. If you look at the trace cursor, I'm moving it to the left slightly to this point on the graph that looks like a high point. So that's going to be our max. Not only is it our max, it's the highest y value the graph reaches anywhere in this window. So that is our absolute max. If I move to the right, and get down near this other low point, you'll see that we have somewhat of a low point, like the bottom of a hill right here on our graph. That's considered our minimum y value. However, it's not the lowest y value this function reaches. If you look to the far left of the calculator, maybe over by -2.5, enter, you'll notice that the y values are even lower here. If I go a little bit to the left, they get even lower. So that means our absolute min is going to be on the left endpoint of this interval at -3. Okay? Lastly, I just want to say that if you look at the right endpoint interval where 2 is, in 2 enter, you'll see the cursor flashing on the right-hand side of the screen. That's considered a local maximum. It's the highest point of the graph if we look over near the right. However, we know if we go back to the left again, maybe around x equals negative 1.2, we see a higher y value than that. So at x equals around negative 1.2, we have our absolute max, and at x equals 2, we have our relative max.